Welcome back, focused learners. Let's jump right into today's explainer. We're going on a seriously wild journey today into the surreal architecture of both human and artificial minds. We're going to look at how neural networks hallucinate completely bizarre entities, how we're actually decoding human dreams, and, maybe the coolest part, how we can use these systems to design and breathe life into explorable 3D characters and fully realized realities.
So take a second and really think about this. What does a computer actually see when it dreams? I mean, when you close your eyes and picture something, maybe a measuring cup or a detailed 3D character from your favorite movie, your biological visual cortex is doing the heavy lifting. But a machine, it doesn't have a biological cortex. It's just processing numbers, weights, and abstract signals. So when those signals get crossed, or when we specifically ask the machine to invent something completely from scratch, what do those abstract processes actually look like? Okay, let's dive into this. We've got a great roadmap today. First, when computers hallucinate. Second, decoding human dreams. Third, building 3D AI dreamscapes. And finally, mastering the AI camera.
Starting right off with step 1, when computers hallucinate, let's get right inside the mind of the machine.
To really understand AI vision, we've got to look at the convolutional neural network, or ConvNet for short. You can think of this as an artificial brain architecture. Imagine millions of simple signal processing units stacked in layers, honestly acting a lot like the visual cortex of a mammalian brain. The lowest layers, they're your basic visual receptors, just detecting simple edges and shadows. But as that signal moves up through the network, those simple edges combine into way more complex character features. We're talking an eye, a nose, a limb, right up until the top layer confidently recognizes a complete object, like a face or a car. But the crazy thing is, these layers are basically black boxes, packed with millions of numeric coefficients.
Back in 2015, researchers at Google actually wrote a tiny 100-line Python program just to peek inside these black boxes. They called this process deep dreaming. Now, instead of training the network to recognize an image, they gave it an image and said, hey, enhance whatever you think you see, creating this wild forward-backward cycle. Get this, it was originally just designed to stop detail loss when zooming in on images. But it accidentally triggered a massive feedback loop. If the AI saw a dark patch that kind of looked like a dog's eye, it tweaked the pixels to make it look exactly like a dog's eye. Run that loop enough times, and bam, the network spontaneously generates these bizarre, chimera-like 3D characters out of absolute thin air. We're talking spontaneous spiders and multi-headed dogs just materializing.
Now, what's really interesting here is the sheer contrast between the input and the output. Researchers feed these networks incredibly mundane inputs, literally just photos of cats sitting by a window, just to study perception. But because the AI has been trained on massive, super chaotic datasets with millions of diverse images, its internal representations are wildly complex. When you ask it to dream based on simple stimuli, it massively overcompensates. It basically forces its learned expectations of complex character designs and surreal structures onto perfectly normal everyday scenes.
This whole phenomenon became known as inceptionism, and it reveals something absolutely crucial. These neural networks are not perfectly logical. Hidden within their 60 million parameters are what researchers call network wormholes. These are essentially blind spots where the computer's vision completely breaks down. In these wormholes, an image of pure random static noise might be confidently labeled by the AI as a cheetah or maybe a centipede. It shows us exactly how the network struggles to make sense of the world, basically papering over its blind spots specifically with its own hallucinatory character designs.
That brings us to part 2. Decoding human dreams. We're flipping the coin here to see how machines are reading our minds.
Look at this setup. That is a patient inside a highly advanced 7T fMRI scanner. In 2024, researchers kicked off this unbelievably ambitious project where they record dynamic neural activity while subjects are actually sound asleep. And the goal here isn't just to see, which parts of the brain are lighting up. No, they want to capture the entire sequence of sleep over time. They are quite literally recording the raw data needed to extract the virtual environments and the specific characters interacting inside the sleeper's mind. Mind-blowing, right?
Let's see how this builds, because turning those abstract brainwaves into tangible video files takes 3 methodical stages. First, they reconstruct real visual stimuli from waking fMRI signals, so mapping waking brain activity to real images. Second, they decode the dream's actual visual imagery. This is the scenes, the characters, what the brain is actually seeing while asleep. And third, they take those fragmented, static dream snapshots and sync them up into a cohesive video narrative.
The tool making this bridge possible is called the Neuropictor Framework. It's fascinating. They take brain activity patterns learned from 64,000 waking images and feed the sleeping fMRI data through the system. From there, researchers can use an AI model, like Stable Diffusion, to actually reconstruct the dream's visual imagery. It takes the visual mapping of our waking reality and transfers it directly into the subconscious, literally pulling out the exact 3D characters and environments the dreamer is experiencing.
But as you know, our dreams aren't just a slideshow of static images, right? They're continuous stories, usually featuring a fascinating cast of characters doing the most bizarre things. So the researchers bring in large language models to act as the ultimate dream interpreters. First, an AI called Lens generates text descriptions for each decoded dream frame. Then ChatGPT steps in, and it is profound to think about this. ChatGPT takes all those discrete snapshots and fluidly weaves them into a cohesive narrative. We're talking a full script, titles, even recommended audio tracks. It is a complete multimedia reconstruction of the characters and stories that live inside our sleep.
Moving on to Section 3, Building 3D AI Dreamscapes. Let's look at how we can actually sculpt these worlds ourselves. So, the crucial point here is that to get the machine to see what you see, you really need this golden prompting formula. Main object plus background plus light plus style. This is your absolute foundation for predictable, high-end 3D generation. Seriously, whether you're generating a hyper-realistic 3D character or some impossible surreal dreamscape, skipping even one of these elements, especially the lighting, forces the AI to guess. And guessing, well, that leads directly to those messy, flat hallucinations we were looking at earlier.
Now, to actually build these worlds, modern workflows rely on a pairing of powerful tools. You've got Nano Banana Pro for generating those hyper-realistic foundation images and Kling 2.6 to animate them with physics-accurate motion. Now listen, if you are designing 3D characters, whether it's the main protagonist of your dreamscape or just a background extra, here is the absolute secret. You must upload multiple reference photos. Feed the AI a front, a side, and a top view of your character. Doing this locks the character's geometry right into the AI's memory. That way, when the camera pans or rotates, your 3D character doesn't randomly warp or lose all its carefully designed features.
And that brings us to our final section, Mastering the AI Camera. This is where we refine the raw output.
The contrast in workflows here is just stark. Think about traditional 3D character animation. You're talking about complex software like Blender, insane learning curves, weeks of rendering time, and needing a $5,000 computer just to run it. AI 3D animation completely flips the script. It democratizes character animation. Because everything is processed on cloud servers, you can build and animate complex 3D characters in minutes just using natural language on an everyday laptop. You are literally just sitting in the director's chair, telling the AI what to do and letting it handle all the brutal physics and geometry.
And this brilliantly illustrates the final hurdle in character design: morphing. Remember those multi-headed dogs from the Deep Dream experiments? Yeah, that is exactly what happens when AI gets a little too creative. If your 3D character starts melting or magically growing extra limbs during an animation, it means your creativity bar is set way too high. Just dial it down to force the AI to stick strictly to your character design and reference images. Another pro tip: fast camera movements will totally confuse the network's frame generation. To keep the illusion of a solid 3D world perfectly intact, you want to always use prompt keywords like slowly, smoothly, and gradually. A slower camera move gives the AI the time it needs to render your characters perfectly. So, we've traced the incredible evolution of these neural networks today, from 100 lines of code making a computer hallucinate bizarre entities, to fMRI scanners extracting a literal cast of characters directly from human sleep, all the way to everyday laptops generating cinematic 3D characters in just minutes. The technology is absolutely here, and it is beautifully surreal. So I want to leave you with this provocative thought. When the friction between imagination and reality is completely gone, and machines can perfectly render our deepest dreams and all the characters within them, what will you choose to create? Thanks for exploring this with me today, Focus Learners. Catch you next time.